Hey there, Year 9s. This is the 2021 Indices and Standard Form Practice Test, which was provided to you on Wednesday, the 21st of July in the morning. Before we get into the solutions and the working out of this, it's highly recommended that if you have a printer, you print this out single-sided and stick this into your exercise book. If you do not have a printer, it's highly recommended that you then copy down these questions into your book and then do the answers within your book as well. So that way you have this as a resource readily available for you when you attempt this formal test, which will be on Wednesday next week. Let's jump straight into it. The layout of this is going to look a little bit different to the test that you got because this is just on my Photoshop program. So just follow the question as is. First one is evaluate these. Now this one is 3 to the power of 3. This just simply means 3 times 3 times 3, which is 27. Nice simple one. Negative 2 to the power of 4. Now you got to be careful if there's brackets involved or not. In this case, because there's no brackets involved, that negative has no association with that power of 4. So it's going to be a negative answer regardless. And this is just 2 to the power of 4, or in other words, 2 times 2 times 2 times 2. Which is 16, negative 16. Now, just be careful. A side note of this is if this was inside a bracket, and I'll put this here. If this was in the bracket like this, this is implying that it is negative 2 times negative 2 times negative 2 times negative 2. And the amount of times the negative pops up determines whether your answer is a negative or a positive. In this case, negative times negative will give me a positive, times a negative will give me a negative again, times a negative will give me a positive answer. Okay. This here is an even number. If the negative, regardless of what this number is within the bracket, if there's a negative inside that bracket and the power is an even number, your answer is going to be positive. So positive if even, and if it is an odd power, your result is going to be a negative. So just imagine this was then a 3, so we'll take this one out. This will be negative times negative, which is a positive, times a negative again, which will give me a negative. Okay, so just be really, really careful of what the power is, if it's even or odd, and whether it's inside a bracket or not. If it's not inside of a bracket, it's just going to be a negative, and then you just go ahead and work out what 2 to the power 4 is. C is 64 to the power of 1/3, which can also be written as the cube root of 64. Okay. In this case, we're trying to find out what number, when multiplied by itself, will give me 64 3 times. 4 times 4 times 4. So my answer, 64 to the power of 1/3, is 4, because 4 times 4 times 4 gives me 64. Now 144 to the power of 3/2. Now there are different ways that we can approach this. The best way to approach this, and this is just based on having good recognition of squared numbers, is that 144 can be written as 12 squared. So 12 squared, I'm just going to manipulate this and change 144 to 12 squared, and this is going to be to the power of 3/2. Whenever you have a power on the outside that's getting multiplied to power on the inside, these two get multiplied together. So this is 12 to the power of 2 times 3/2. 2 times 3/2, the 2's cancel out. And this is just equal to 2 to the power of 3. Or, 12 to the power of 3. So this is just 12 times 12 times 12. Now, remember, you can use your calculators for this test. So if you don't know what 12 to the power of 3 is, you can just type this in. So how you would approach this, I got my calculator out. We type in 12. And this button right here is X with a little square on top. When you press that button, that just indicates that we can try to find out a certain power that's not just squared, it can be any power. So 12 to the power of 3 is 172a. So this is equal to 172a. Now alternatively, you can put in 144, I'm pretty sure. If you want to put this as a power and then as a fraction, this can be a powered fraction. So we can do 3/2. Again, this will give us 1728. This can also suffice if you are struggling. Same with the 64 to the power of 1/3. Now, e 2 to the power of 0 plus 2, any number rather to the power of 0, regardless of whether it is a pro-numeral or a number, will always equal 1. So this is just implying 1 plus 2, which is 3. Okay, question 2. I'm just going to wipe this off so I can have a little bit of room. Question 2, write these in standard form. We always know that standard form always starts off with a number between 1 to 10. So we're going to look at our significant numbers. This is 1, 1, and 2. So this is 1.12 times 10 to the power of, and how you would conduct this is I always count how many numbers are to the right of if you were to put a decimal point here. So let's just imagine the decimal point is here because it's 1.12. There are 1, 2, 3, 4, 5. So our power is 5. In this case here, our first significant number is 8. So this is going to be 8.21 times 10 to the power of a negative because it's a number less than 1. And all we do is just simply count how many zeros we have here, including this first one here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 8.21 times 10 to the power of negative 9. Question 3, write these as basic numerals. 2.9 times 10 to the power of negative 4. This is kind of the inverse of this rule here. So we look at this negative power. So we're going to write 4 zeros, put a decimal point here, and write this number here without the decimal point. Simple as that. In this case here, we have 1.08 times 10 to the power 8. I'm going to start up by writing this number here. Now how I approach this is I count how many numbers are after the decimal point here. This is 2. So I'm going to subtract 2 from what this power is. So 8 minus 2 is 6. That's going to dictate how many zeros are right. So in this case here, our answer is 108 million. Question 4. When expressed with positive indices, this expression here is equal to 1. Now we have a division. When we have a division, the bases that are same, what happens to the powers, they get subtracted from each other. In this case, we have an A with no power and an A with no power, so they just get cancelled out with each other. T to the power of 9 divided by T to the power of 2. This is T to the power of 9 minus 2. So this is T to the power of 7. And M to the power of 2, take away minus 8. Okay, so we've got a take away with a division, and then we have this minus 8. So this is actually 2 take away minus 8. 2 take away minus 8, or 2 minus negative 8. This is equal to 2 plus 8, which is 10. So this M has to be to the power of 10. Okay, be careful of this pesky little negative. Okay, it can dictate whether it turns into a positive, depending on its position. If it's as a denominator and you're taking away a negative, it will turn positive. T7, M10, answer is D. Question 5, we have 5h to the power of negative 4, all in brackets to the power of 3. That 3 gets applied to both the 5 and the h to the power of negative 4. 5 to the power of 3 and h, when there are two powers, they get multiplied, where the inside bracket with the outside bracket. Negative 4 times 3 is negative 12. Now we can't see the solution here. In fact, we can't see any solution where there is a negative index. So this obviously tells me that the 5 to the power of 3 has to be in the top, and h to the power of 12 must go in the bottom. Now we also can't see the 5 to the power of 3, so we have to work out what 5 to the power of 3 is, which is 5 times 5 times 5, which is 125. So 125 over h to the power of 12 is our solution. Question 6. Now question 6, Apologies for this one. The correct solution is actually not here. After looking back at this, I realized this error, but the damage is already done. I still want to show you the working out because you will get a question that looks like this, and I'll show you what the proper solution is. So this right here, we have to put this in a format where it shows only a positive index. In other words, this is going to be, computer just glitched out of me. This is going to be 1 over y to the power of 8. That's the first part. The second part is that we can split this square root to both the numerator and the denominator. So this will be the square root of 1 over the square root of y to the power of 8. We know what the square root of 1 is. This is just 1, because 1 times 1 gives me 1. And y to the power 8, what I'm going to do is I'm actually going to write this as y to the power of 8 to the power of half. Now I'm purposely doing this so I can get a proper power for this. 8 times half, or half of 8, this will be y to the power of 4. This is the most simplified version that we can get of this. Unfortunately, this solution is not there as an option. Okay, I've double checked the actual cat itself. There is a proper solution for a question that does look like this. The most important part is the approach of how to do this. Okay, so pay attention to that. Apologies for that. Totally my fault on that one. Question 7, we want to simplify this down as much as we can. It does look a bit intimidating, but as long as we know that because there's a division involved, we just have to subtract the same based powers. First, let's look at the number 40 over 10. This can just simplify down to 4 being on the top. Let's look at L to the power 12 divided by L to the power 11. That's just 12 take away 11, which gives me 1. So L to the power of 1 is just simply L. K by itself and K by itself, despite that it's written in a different orientation, they just get simplified. And here we have f to the power of 12 divided by f to the power of 20. This will result with a negative power. So this is f to the power of negative 8. Now this is an option, so this has to be written in this format: 4L over f to the power of 8. 4L over f to the power of 8 is this C here. Question 8, we're now going to simplify the following expressions. When it comes to multiplication, the bases that are the same have their powers added. So m squared times m4, this will be m6. y2 and y3 will give me y5 because I'm just adding these two bases, these two powers together for the y's, and these two powers here for the m's. And because it's times, you just add them. Same concept. All of them are being multiplied together. So this is m. We've got 1m here. We've got 9 here. And we've got 4 here. Before we get to that, I can see that there's a 6 popping up in front. 6 doesn't have to get multiplied with any other number, so it's going to start with a 6. So m, 1, 9, 10 plus 4 is 14. So m, 14, and with the y's we have a 4, we have an 11, and we have a 1. So that will give me 16. Y 16. So just simply adding the powers of the same base. If there was another number that was in front of this m here, like a 2, we would have to make sure that we do 2 times 6 and then write 12. Because 6 is just by itself, we can just leave it as is. When it comes to division, of course, we know that the powers get subtracted. So 8 take away 2 because of the powers of m. This is m6. And y6, y3, 6 take away 3 is just 3. So there's a simplified version. We've got a bit going on here now. So that's why there's a little bit of space underneath here. We can, I guess, nut this out into because there are different ways that we can approach this, but we can nut this out. Maybe we'll just collect the top and then collect the bottom and then simplify accordingly. So all the top terms get multiplied together, so the powers of the same base get added. So the top part will be m5 the 3 plus the 2, and y8 all over m squared y5. Okay, so we've just done top times top, bottom times bottom, adding the powers at the same bases. Now we can just go ahead and do a normal subtraction because there's a division. This will be m to the power of 3. 5 take away 2 is 3, and 8 to take away 5 is also 3. So it's m to the power of 3, y to the power of 3. Sometimes you'll get textbooks that can also simplify this down further to have it in this format, my to the power of 3. But this answer here will still suffice. That's completely fine. This term here, pretty much the same as this. The only difference is we have a division, but I want to force this to be multiplication. So we just apply our keep, change, flip. So we're going to keep the first term. Change the division to a multiplication, and then flip the second term. So the m4y3 is on the top, and m3y3 is on the bottom. Now we can go ahead and do the same process as what we did in the previous question in D. M8, M4, this will be M12. Y9, Y3, this will be Y12. All over M4, M3, which is M7, and Y1, Y3, which is Y4. And let's just go take away our powers with the same bases. This would be m to the power 5, as 12 minus 7 is 5, and y to the power of 8, as 12 minus 4 is 8, and there will be our final solution. F, here we have a division. It's just written in a different format. If you want, you can write this as 12m5y6 all over 6m squared y squared. And there we can just simplify accordingly. We've got some numbers to simplify first. 12 and over 6, this just simplifies to 2. How many 6's go into 12? 2. M5, m squared, m3, and y6, y2. This is just y4. So here's our final solution. Alright guys, we are on the home stretch now. I just realized I probably didn't give myself enough room here for the solution. So I'll write a little bit here on the side, and then I'll try my best to fit this in. If I tend to just trail out that way, apologies. So the first thing we want to do is we'll notice that there are terms within brackets that have powers on the outside. Let's just try to expand these out first so we don't have any brackets. The numbers that are also there, they can also be simplified down before we get to our next lines. We have this 8, this 4, and this 18. Okay, so let's cancel this 8 to make it a 2 to turn that into a 1. Because our highest common factor between 8 and 4 is 4. 4 goes into 4 once, 4 goes into 8 twice. And now we have this 18 and this 2. That turns into a 1, with this turning into a 9. So this is 1, this is 1, this is 9. So the first term, the only term on the top, is a 9. We have this t squared, it's still here. That has no brackets with it. We have a c to the power of 3 to the power of 3. When the power is on the outside, it gets multiplied with the power on the inside. So this is c9. We have a t squared to the power of 3, so this will turn into a t6. And we have this c squared tagging along. All over t8, 2 times 4 is 8, and c6. Okay, that's our first part. Let's just do a little bit of tidying up. I can see here, we can just do this in one step. We've got this 9, t squared, so that's t2 times t6, so that gives me t8. And on the bottom is also a t8. So these technically get cancelled out because it will be t8 divided by t8, which is just 1. And we have a c9 times c2, so this is 9 plus 2, c11 take away the 6. So 11 take away 6. This will be c to the power of 5. And that is our final solution. So after all this jargon here, once you've done your simplification, you'll end up with 9c to the power of 5. So I guess didn't really need to trail off. H, we have now got these negative powers. Okay, we now got these negative powers. So what I do want to see is when you do have a negative power, once you've done all your expanding out, you want to be able to write this without showing negative indices. It's a basic concept. I'm not going to penalize you if you don't show it, because the main criteria I want to see is you being able to show that you can expand this out accordingly. But the common consensus is that you should be able to show it in positive power index. Okay, unless the question states otherwise. Pretty sure within this question here, if we go back, it just says simplify the following expression, so there's no penalty for showing it without positive indices. I'm still going to do it anyways, but you won't get penalized. Okay, so this -3 gets applied to the m, the y, and the p all together. So -2 times -3 is positive 6. Y, -3 to the power -3 is y 9. All over p to the power -1 to the power -3, this is just p to the power 3. And in fact, we don't actually have to simplify it any further because all of these negative powers are actually turned into positives. So this is our final solution. With I, a little bit different. We've got a bit more going on. We'll again apply this -2 to every single term within the top and the bottom. And we'll simplify it as much as we can before we do the multiplication. So this is going to take a bit to tackle. Let's have a go. This will be x to the power of 4, -2 times -2, y to the power of -2, all over z to the power of -6, and t to the power of -6, all being multiplied by x to the power of -4, y to the power of 1, so we'll just leave it as y, all over z to the power of +4, t to the power of -5. So all I've done is applied this power to every single term here, and this power to every single term here by multiplying it with each base's power. Okay. Next thing we can do is do a little bit of tidying up. We can multiply this term with this term here, numerator with numerator, and denominator with denominator, and then see if we can do a little bit more tidying up. So we have this x to the power of 4 times -4. So this is 4 plus -4. This actually gets simplified down to 1. So these two terms here technically cancel out. We also have a y to the power of -2 times 1. So this will turn into a y to the power of -1, as -2 plus 1 will give me -1. Z to the power of -6 plus the 4. This will give me z to the power of -2. And t to the power of -6 times t to the power of -5. This ends up being t to the power of -11. Now, if you were to just leave the answer like this, that is completely fine. But if the solution said it only wanted to show positive indices, anything that is on the top that has a negative goes into the bottom, and anything on the bottom that shows a negative goes into the top. And so this is actually a really simple concept. All we're doing is just flipping everything around and taking away those negative powers. So this can also suffice if it asks for positive indices, but this is also fine for this specific type of question. All right, we are up to our last question. Now, I don't know if people got stumped on this one. When you see the marking scheme for this, it is recommended that you show working out because it will be worth more than 1 mark. If you were to just simply put this into your calculator and get a fraction or an expression of some sort or some answer, you'll just get 1 mark still. This could be based on running out of time. But the actual working out for this is as follows. This 5/3 gets applied to 1 and applied to the 27. In other words, this is going to look like this. Let's change the color quickly. 1 to the power 5/3 over 27 to the power 5/3. Now, 1 to the power of anything will always give me 1, regardless of whether it's decimal power or fraction power. It will always be a 1. Okay, so just be really, really careful of this. In this case here, this will stay as 1. Now this 27, 27 to the power 5/3. This seems like a very weird concept, but I do know 27 is 3 times 3 times 3, and it's not obvious. Okay, it's not obvious, but we can write this here as 3 to the power 3 to the power 5/3. And what we can do is apply the multiplication of this power with this power because it's inside outside bracket. So this becomes 1 over 3 to the power 3 times 5/3. The 3's get cancelled out, and this just becomes 3 to the power of 5. And we can use our trusty calculator to work out what 3 to the power of 5 is, and this will be 243. So this final solution is 1 over 243. And there it is. This is it. You would get all your marks for this here. But again, if you wanted to put this into your calculator, put into the bracket fraction 1 over 27, go across, close that bracket, to the power of another fraction 5/3, 1 over 243. So if you were just to write 1 over 243, 1 allocated mark, but you will not get the full marks because you need to show this working out here. Alright guys, I'll try to get this under 30 minutes. I think I did relatively well. See how you went and give yourself some ticks, and hopefully this will help you out with the real cat, which will be next week on Wednesday. Till then guys, I'll see you in the next video. Bye bye.